Hello everyone, I'm Amar Shakir from AD, Application Development. I study in Technical Trainers College in Riyadh. In this tutorial I will demonstrate how I make this robot, which is my bachelor project. My project is about creating an autonomous vehicle, autonomous car, which moving around without hitting obstacles. Obstacles, which means walls, human, chairs, anything that it faces. This project is, I create this project by using Raspberry Pi, Breakby, and Mindstorms Lego, and ultrasonic sensors. For Raspberry Pi, why I am choosing Raspberry Pi? It's a small device, a small computer, which is called microcontroller, which is low cost. It costs about $35. It has an operating system which can be downloaded and stored in SD card. Any SD card like that we have on Samsung devices, Samsung phones, and it has a lot of and it's powerful to run whatever you want. For example, we can create a smart house by using this device. What is Raspberry Pi? As I said, it's a low cost, a small size. You can see it. It's like smaller than my hand, a small size that plugs into a computer. It has a lot of inputs and outputs. We have two USB 2, and we have Ethernet for connecting to internet. We have HDMI port for connecting for connecting monitors, and we have here the SD card board, which we can install the operating system on it, and we have audio board. The second device that I used to create this project is Breakby, which is a small device, contains 9 boards for sensors and motors. As you can see here, we use this sensor and these motors. In order to communicate with Raspberry Pi, we are using Breakby, which is this one, Breakby, to transfer the orders from Breakby to motors and this sensor, ultrasonic sensor, and to also get the feedback from sensor to Raspberry Pi through Breakby. So Breakby is just about interface between Raspberry Pi and the sensor, ultrasonic sensor, and the motors. Breakby contains 9 boards, 4 of them for motors, and 5 of them for the sensors. We have a lot of sensors. I use just one sensor here, ultrasonic sensor. We have a light sensor and many kind of sensors. The third part that I use to create this project is Mindstorms Lego. What's Mindstorms Lego? It's a combination between hardware and software kits, which can be reprogrammable, and with this we can create a robot with this Mindstorms Lego. Also, it includes set of sensors. For example, we have EV3 sensor and a lot of different kinds of sensors, and we have also this kind of sensor, which is ultrasonic sensor. This ultrasonic sensor is defining the obstacles, and we can avoid the obstacles by using this robot by using Java language, and we'll see now how the code will work.
Okay, before start coding or explaining the code, we have to prepare NetBeans or to configure NetBeans in order to send the executable program to Raspberry Pi remotely. In order to do that, we have first of all to know the IP address for the Raspberry Pi. Now I'm on the Raspberry Pi desktop, and this is that terminal. I open it from here, and we have to know the IP address for Raspberry Pi. We type sudo ifconfig. It will bring to us a lot of IPs. Will be the IP address for Raspberry Pi. In my case, 192.168.1.10. Now I have the IP address for Raspberry Pi. Go back to NetBeans. We use the NetBeans program to program the robot using with Java language. First, we have to configure the options for NetBeans. We go to Tools, Java Platforms, and add platform. Remote, we choose Remote Java Standard Edition. Next, we give it a name. RB1, for example. The host, which is the IP address for Raspberry Pi, 192.168.1.10. The username for Raspberry Pi account, which is by default Pi. The password also by default Raspberry. And now, before we click anything, we have to here click create, and we choose the EJDK 1.8.0, which is available on Oracle website, embedded Java. We choose it, and then we create compact 3 all for full GRE. I will use compact 3. We check this too, and we press create. It will take some time. Now, after it finished, it's successfully created. We click finish. After it finished connecting and preparing everything, it will appear this window. To make sure the connection is okay, we click test the platform. It will test the platform, and if the connection is okay, it will be showing a message that the connection is successful. Now it shows the message that says the connection to a remote platform is successfully established. So we are okay now. We click close. By the way, I'm using a remote desktop connection to connect to Raspberry Pi remotely using the IP address for Raspberry Pi. For the code, here's the code for the robot. I will explain the most important part of the code. I have two options. I program two options that the user can choose. One of them controlling the robot manually or automatically. For controlling the robot manually, I'm using key event. I'm using arrow keys with key events. This is the code for controlling the robot manually. When the user press a key, arrow keys, one of the arrow keys, it will do this function, and it will check which key is pressed. Is it the up key or down, right or left key? And it will do the instruction inside each case. I put it in a switch, and I have 4 cases for up, right, left and down. The default will be false. Here I'm for controlling the speed, I'm using motor.set command output and the speed. The speed is here a variable, because I'm asking the user to input the speed when he starts the program. This is for controlling the robot manually. When the user chooses to control the robot automatically, the function that will be running, this function public void run, it's an auto loop. It will also get the speed from the user, and it will autonomously running, it will continuously running until it's face an obstacles. Here we put a condition that if the sensor gets an obstacles in a range less than 30 centimeters, it will rotate. It will rotate to the right, 90 degrees to the right, and it will continue moving forward. And also, if it's find an obstacles, it will rotate again and again until the user stop the program or choose to control it manually. Also, I'm using thread to stop the robot when it's controlling manually. The thread, the job of a thread is when the user pressing the keys, it will do the program will do this function. For example, the user press up key, the robot will go forward. The program just do one function at a time. So in order to do two functions in the same time or in parallel, we use a thread. So when the user press the up key, the program will send to the robot to move forward. At the same time, will check if the robot face an obstacles in front of it or not. If it face an obstacles, it will stop the first function, which is moving forward, and also it will stop the thread. So whenever the robot face an obstacle, it will stop both of this function, the thread function and the moving forward function. Now we'll move to the practical part and we'll do a demonstration for this robot. Through Raspberry Pi, I already sent the executable file through NetBeans to Raspberry Pi remotely. It's in file called CD NetBeans project. break by test slash dist. If we want to see what's inside this file, we'll see break by java.jar, break by java test.jar, and we see a lot of files: library, lex terminal, desktop, start stream, readme.txt. By the way, start stream.sh, what does it do? Here in the program, in the Java program, I execute this code. This code is to execute an instruction in the terminal. So here I wrote sudo space dot backslash start underscore stream dot sh. What does this file do? It's for opening the camera and providing streaming video, which will the user see in his own laptop. So in order to start the program, we have to write java space dash jar space, and we write the name of the program, break by java test.jar. Enter. This is the user interface. The user can have two options, as I said, manual or automatic. Also, he has to put the speed of the motors. The speed must be between 0 and 255 maximum. Let's assume that we'll put 255 and we click enter. Now when the user click automatic, the robot will move until it faces an obstacle. If it faces an obstacle, it will go, it will rotate 90 degrees and it will continue. If I press manual, the robot will stop until the user presses a key, one of the arrow keys from the keyboard.
That was a demonstration of my project. I hope you enjoy it. Thank you very much.